but I kind of look at three levels of drift that have created that you need to then start to manage from this. One is model drift. But model drift is when I make a prompt, right? I prompted the model and I'm getting a different response than we had tested, than we expected. And that can happen for a lot of reasons. The underlying model can change. If the systems kind of learn the wrong things, the world that the model lives in, the workflow that it's deployed in has changed in subtle ways. That kind of goes into model drift, is how I would call it. The next type of drift, though, is kind of started to emerge as you get into these reasoning models, which is behavioral drift, right? And so with these reasoning models, you make one prompt, but the model itself is doing multiple turns before it comes back to an answer. That actually introduces all sorts of additional opportunities for error, right? So
It's
the
the
model,
wings problem. Like you get a
yeah,
little bit in step one, and now you're going, and it sort of magnifies
yes,
itself.
absolutely. As you get this complexity, you can definitely get hey, the butterfly flapped its wings in China, and then my weather changed in Boise 10 days later, right? I mean, it's small changes can amplify themselves because if in step one of my agentic flow, the reasoning process breaks down to some level, then that actually compounds, right? As I go through now 10, 20, 50, 60, 70, and a lot of more difficult agentic flows right now, it's not that uncommon to go through, 60, 70, 80 turns in order to get it done, right? If you're trying to really accomplish something really big, if not even more than that. And so problems amplify themselves along the way. And these reasoning things introduce another problem, like the amount that the model is going to reason depends on everything that's happened prior. And, so in other words, like a good example that probably everyone's experienced at some level, you're having a nice long conversation with ChatGPT or Claude or whatever, and you're really in the groove and you're jamming and it's going to be great. And then all of a sudden it rushes to an answer and it gives you something, right? That's because these models panic when they're close to running out of context, right? And so context is, think of it as this, the amount of in-process memory effectively that the agent has to work from. And at the beginning of a conversation, especially with these new models, it has lots of context and it can go, and then it's kind of like, oh God, I'm done. Like I've run out of budget, right? And it can be, and systems are starting to evolve too, where there's literally more of a little bit of a budget allocated to these calls. And so it can literally just be, hey, I've run out of the compute budget I had available to me. And so that's this behavioral drift, is I might be getting different behavior from time to time because of small changes in the reasoning logic or other pieces like that. And then you can start to get agentic drift, and again, especially as you get these more goal driven agents that are making their own plan, choosing how they attack the problem. Well, maybe they made, each time they're making a slightly different plan. They tend to call tools, right? Well, maybe there's been a change in not in the model, not in the prompt, not in whatever, but in the tool itself and how the tool operates. So all of these or we add one more tool and now it chooses the wrong tool, right? Because now you've given it a choice of more tools, it's more likely to choose the wrong tool in some situation. So anyways, there's these different levels of complexity, I think, and probably, I don't know that people have to necessarily understand all of the details of all the, there's three different levels of agents and three different levels of drift and whatever. I think the meta point to take home is it's a different level of challenge that we have to deal with in terms of how we monitor it, validate it, and ensure that it's working in the ways we expect.